This is section 6.5. We're going to look at the volume of pyramids and cones. And of course, our learning goal is that students will understand how to calculate and use the volume of pyramids and cones. So here's an example. This is kind of how the volume formula is derived for the volume of a pyramid. If you think about this little cube here as like one of those little wooden puzzles that you can kind of take apart and put back together, if this little cube is a puzzle, it could be divided into 3 congruent pyramids. So this red pyramid here is exactly the same as this blue pyramid here, and that's the same as this green pyramid here. They're all just kind of turned different directions. So notice that the blue one has a square base, the green one has a square base, and the red one has a square base as well. So all 3 of these pyramids are the same. That means that the volume of each one of these 3 pyramids has to be 1/3 of the volume of the prism. So that's where our formula for the volume of a pyramid kind of comes from. Proving it is actually a lot more difficult than that visual representation, but it turns out to be true. So we're going to work with it. So the volume of a pyramid is equal to 1/3 of the area of the base times the height of the pyramid. So remember, any prism can be found, any prism, the area formula is the area of the base times the height. But for a pyramid, the area formula is not the area formula, excuse me, the volume formula is 1/3 of the area of the base times the height. It's 1/3 of the volume of a prism. So we would calculate the area of the base of the figure, whatever that was. We'd find the height of the figure, whatever that is, and we multiply those together and divide by 3. Remember, the slant height might be the value that's given to us, but we can find the slant height by drawing in that triangle inside of the pyramid like that and looking at that little right triangle right there and using the Pythagorean theorem if we need to find the height. So let's do a couple examples with pyramids. Let's find the volume of this pyramid. So notice that the base of this pyramid is a rectangle. It would form a rectangle if you just drew the base. Kind of looks like this. This length is 4. This length is 5. So the area of the base is 4 times 5, which is 20, and in this case it would be 20 square feet. The height of this pyramid is easy. It's already given to us. The height is equal to 6 feet. So the volume is 1/3 times the area of the base times the height. So that's going to be 1/3 times 20 times 6, and in this case that would be cubic feet, because of course we're working in volume. So what I'm going to actually do is multiply 1/3 times 6 first. 1/3 times 6 is 2, and then all I have to do is 2 times 20, so I can do this in my head, and 2 times 20 is 40. So the volume of this pyramid would be 40 cubic feet. Let's do another example. Let's find the volume of this pyramid. Now this pyramid is kind of weird looking. It's what we call an oblique pyramid because it's not like straight up and down, right? The height isn't directly over the center of the base. That's okay. We can still use what we know to find its volume, right? Let's first consider the base of this guy. We can see that there's a right angle right here. That's important because it tells me that the base is a right triangle. So use what you know. This length would be 6, that's coming from here. This length would be 7, that's coming from here. And it's a right triangle. So the area of the base, 1/2 base times height for a triangle, so 1/2 times 6 times 7, so that would be what, 3 times 7, so that would be 21. The area of the base is 21. The height is given to us right here, so the height is equal to 8. So now let's calculate the volume. the volume is equal to 1/3 times the area of the base times the height. So that's going to be 1/3 times 21 times 8. 1/3 of 21 is 21 divided by 3, so that's 7. And 7 times 8 is 56. Now let's go back and make sure we include our units. So that would be cubic meters. 56 cubic meters is the volume of this pyramid. All right, now let's look at cones. Finding the volume of a cone is related to the volume of a cylinder the same way that the volume of a pyramid is related to the volume of a prism, right? Remember we said we could fit 3 pyramids inside of one prism? Well, you can fit 3 cones inside of one cylinder. They might not be nice right cones like this guy is, but you could actually fit 3 of them in there. It's kind of weird, but you could. So we say that the volume of a cone is equal to 1/3 times the area of the base times the height. But of course, since this is a circle, whoopsies, this guy is a circle, the area of the base is given by the formula pi r squared. So my volume will be equal to 1/3 pi r squared times the height. So that gives me the area of the base that I want, and then we need to know the height. And of course, pay attention because we might have been given the slant height there. So let's do an example. Find the volume of this cone and then round to the nearest whole number. All right, so I clearly have the radius. The radius is equal to 3, but I do not yet know the height. But I've also been given this value, which is the slant height. So what we're going to do is we're going to use this right triangle right here to help calculate the height. Right? This guy is 3. Here's my height. The slant height is 5. You may have already realized that this has to be 4 to make it a 3, 4, 5 right triangle, but if you didn't, 3 squared plus h squared equals 5 squared. So that's 9 plus h squared equals 25. Subtracting 9 from both sides gives me h squared equals 16. Then take the square root of both sides, which tells me that the height has to be 4. Woohoo! Okay, now we know that the height is 4. We can find the volume. Volume equals 1/3 times pi r squared times the height. So that's going to be 1/3 times pi times 3 squared times the height, which is 4. So let's multiply this out. I got to do my exponents first. So 3 squared is 9. Then what I'm going to do is I'm going to do 1/3 of 9. Multiply that together first because it's easier. 1/3 of 9 is 3. So that's 3 pi times 4, which is 12 pi cubic inches. However, the direction said to round to the nearest whole number. So I'm going to approximate pi with 3.14 and then multiply that out. So 12 times 3.14 is going to be equal to, I don't know, about 38. So rounding to the nearest whole number would give me 38 cubic inches. And that's it for the examples that I have for pyramids and cones. If you can do prisms and cylinders, you can do pyramids and cones. Just remember you might have that extra step of having to find the height. All right, so now one more example. Oh, I said I was done with examples, but I think I put them in the wrong order. Let's go ahead and do this anyway because we had example 4. Now we have example 3. Sorry. Let's go ahead and do it. All right, we can see that the radius equals 8. The height has already been given to us. It's 12. So try it on your own. Volume is equal to 1/3 times pi times the radius squared times the height, which is 12. So that's going to be 1/3 times pi times 64, which is 8 squared, times 12. Now think, what's going to be the easiest to multiply together first? I know that 3 divides evenly into 12, so I'm going to do 1/3 times 12 first. It's all multiplication, so I'm allowed to do that. 1/3 of 12 is 4. So we have 4 pi times 64. 4 times 64 is, let me see, what's that going to be equal to? 4 times 64, that's something I should just know, but 24, yeah, 256. So that's 256 pi. But rounding to the nearest whole number would be 256 times 3.14, which is about 804. So this case would be 804 cubic centimeters would be the volume for this cone. Okay, so now we really are done for reals this time. Go back in, put your left-hand column questions in, make a complete summary, make sure you include the two formulas that we learned for here, and maybe even how they're related to prisms and cylinders.